What if the earth itself had a memory, not written in books or spoken in voices, but pressed quietly into stone over ages beyond our own counting? When we look at mountains, cliffs, and deep canyon walls, we see layers of rock arranged like pages in a book that has never been opened fully. Each layer holds the dust of ancient landscapes, the chemistry of vanished seas, the marks of storms long faded. These layers are what geologists call strata, and together they form a slow archive of the planet's breath and silence. Unlike human memory, which fades quickly and bends to emotion, the memory of Earth is stubborn and steady, though it speaks to us only through patient study. If we soften our pace and listen in this way, the stones begin to tell their story. Now we pause for a moment on the idea of scale. A single layer of rock may take thousands or millions of years to form. To us, it looks still and solid, yet it is the record of countless grains of sand carried by rivers, or shells of tiny organisms sinking into deep seas, pressed together under weight. Over immense time, these small fragments turn to stone, and stone becomes a record. It is like a diary written one grain at a time. In the rhythm of this accumulation, we sense something larger than ourselves, an earth that records without effort, simply by being. Within these layers, we find traces of air once breathed, trapped as bubbles in ancient ice or chemical signatures in sediments. For example, scientists measure isotopes, which are tiny variations of atoms, to reconstruct the temperature of oceans millions of years ago. It is a delicate task, like listening for a whisper in a vast hall, but slowly patterns emerge. Warmer ages, colder ages, long cycles that shaped the path of life. The rocks do not exaggerate. They record quietly, offering evidence with no intent, only persistence. Yet our knowledge has limits. The record is incomplete, broken by erosion, or hidden deep beneath the crust. Some chapters are lost forever, washed away before they could be pressed into stone. Others are still buried far below where we can reach. We piece together what remains, but we must accept that our picture is partial, blurred at the edges. What we cannot see may change the story, and so we read with humility, aware that absence of evidence does not mean absence of events. Still, even partial records give us direction. The language of stone is subtle. Shifts in mineral color, the presence of fossilized shells, the angle of grains that show an ancient wind. Each detail is a marker, a signal left behind without intention. Taken together, they create a chronology, a timeline far longer than any human memory. It is as if the earth keeps time not in hours or years but in eras, each one a layer gently resting upon the last. Let us try a small thought experiment. Imagine standing before a cliff face where hundreds of layers are visible. Each band is a season, a flood, a long summer, a winter storm, pressed into stone. If we could speed up time, we would see layers forming like the growth rings of a tree, but at a pace so slow it escapes ordinary sight. Step forward in this experiment and think of a distant future, millions of years from now. Today's soils, rich with traces of us, bits of plastic, residues of industry, fragments of bones, may harden into rock and join the record. Future beings, perhaps not human, might read these layers and see our brief presence as a thin, unusual stripe in the planet's memory. Step one more pace, and consider if Earth itself, as part of a larger organism, uses these layers as its long-term memory, storing signals that may serve purposes we cannot yet imagine. Perhaps the act of remembering is not only for us to discover, but for the planet itself to carry. We cannot know, but the thought lingers softly. The careful study of these stone memories reminds us that the Earth holds a past far deeper than our own histories, and yet it also hints at a future in which our traces will be absorbed, altered, and stored. It is not a dramatic process, not a sudden revelation, but a continuous unfolding. Rocks do not rush, and in their slowness there is calm. Whether or not we think of Earth as a living organism, its memory is undeniable, pressed into the world around us. And so we rest with this open thought. The planet remembers in its own way, and by listening we become part of that remembering, even if only for a moment, before time carries us gently onward. What if the universe itself spoke in the quiet language of systems, and what we see around us were only fragments of a larger design? When we think of the word system, it may sound technical, but in essence it means a set of parts working together, connected by flows of energy or matter. In daily life we already live among them. A kitchen where fire warms water and steam escapes. A city where streets, pipes, and lights form a woven pattern. Even our own bodies where organs coordinate like instruments in a slow orchestra. Now let us stretch this sense of connection to the scale of planets and stars. The Earth is not simply a rock floating in space, but part of interlocking processes that sustain weather, climate, and life. The circulation of air, the cycling of water, the growth of forests, these are not random acts but linked movements. Together they form what scientists call Earth's system, a self-consistent arrangement where changes in one part often ripple to others. If ice melts, seas rise. If forests grow, air shifts in composition. Nothing stands apart. In the vastness of space, astronomers use the same word to describe larger arrangements. Solar systems, where planets orbit stars, and galaxies, where stars orbit galactic centers. Each is a web tied by gravity, radiance, or invisible matter. When we look at Earth with this lens, it becomes natural to wonder whether it too belongs to an even greater system, perhaps one we do not yet perceive fully. Now we pause for a moment on how these systems operate. At their heart are flows. Flows of heat, flows of light, flows of particles. On Earth, sunlight falls on oceans, warming water and driving winds. Those winds push clouds, which carry rain to distant lands. The rain nourishes rivers, and rivers return water to the sea. Each step links to the next, in a cycle that repeats without need for intention. In this repetition, there is a kind of rhythm. But while the cycles are visible, the boundaries of the system are harder to define. How far does Earth's system extend? Does it stop at the atmosphere, or does it include the moon's pull-on tides, or even the constant streams of particles from the sun? We cannot be sure, and definitions change depending on perspective. This uncertainty reminds us that our understanding remains incomplete. The absence of a clear border does not mean there is no system, only that our categories are tools, not truths. To study these links, scientists look for traces, the subtle footprints left by processes over time. We see rings in ancient trees, recording drought and rainfall. We find sediments at the bottom of lakes, layered with pollen grains that whisper of forests long gone. We measure gases trapped in bubbles of ice, revealing shifts in atmosphere from ages past. Each record is a clue to how the Earth system has shifted, adapted, or faltered. None is absolute, but together they build a map of interactions, a quiet testimony that nothing in nature stands alone. Let us imagine, gently, a small experiment of thought. Suppose we could see every system around us glowing faintly, each connection illuminated like threads in a vast tapestry. The rivers would glow as lines feeding the seas, forests would shimmer as they breathe carbon and release oxygen, the atmosphere itself would hum with currents. Step further in this vision, and the glow would extend outward. The pull of the moon on our tides, the streams of energy from the sun, the faint tug of distant planets. Step once more, and the glow would widen to galactic scales, where stars and clouds of matter weave a structure beyond imagination. In this view, Earth is not an isolated island, but a node in an endless web. The quiet conclusion we may draw is neither final nor absolute. Systems exist because connections exist, and our planet is saturated with them, within and beyond. Whether we call this a larger organism or simply a network of processes, the result is the same. Earth is part of something greater than itself. We need not define that something fully. Only rest in the awareness that connections bind us, and that to live is to take part in flows much older and larger than we are. What if the shapes we see around us were not coincidences, but quiet echoes repeating across scales, from the smallest leaf to the largest galaxy. Patterns in nature often emerge without a plan, simply because energy and matter tend to flow in certain ways. When water branches into streams and rivers, when blood divides into vessels and capillaries, when lightning forks across the sky, the branching looks strikingly similar. The word for this repetition is fractal, meaning a shape that resembles itself at different sizes. We can find such forms everywhere once we begin to notice them. Now we pause gently on this idea of recurring shape. A seashell spirals outward, growing but never losing its curve. Galaxies, vast beyond comprehension, turn with spirals of stars that echo the same motion. Ferns unfold leaves that are miniature versions of the plant itself. None of these shapes are identical, yet the resemblance is strong enough to remind us that nature often reuses its designs. This repetition may not imply intention, only efficiency. Certain patterns are stable, others are not. Over time, the stable ones persist, and so we encounter them again and again. The mechanism behind these repetitions is often simple. Growth tends to follow rules of addition and division. A tree sends one branch upward, then divides into two, then four, each smaller but shaped by the same rule. A crystal forms as molecules stack in repeating arrangements, building a larger order from small steps. Fluids swirl into spirals because rotation distributes energy evenly. These are not conscious acts, but the natural result of physics and chemistry. By observing them, we sense that what happens in one domain often mirrors what happens in another. Still, we must remain careful. Patterns can mislead. Our minds are skilled at seeing resemblance, sometimes where none truly exists. The spiral of a galaxy and the spiral of a shell arise from different causes, despite their visual similarity. We cannot assume that likeness means connection. The absence of a proven link does not mean there is none, but it does remind us to step lightly between metaphor and fact. Our interpretations remain tentative, held loosely like a shell in the hand, admired but not overclaimed. To trace these repetitions scientifically, researchers look for markers in data. They measure branching angles in river deltas, compare them with those in lung structures, and note how both maximize flow. They study mathematical curves that describe spirals, finding the same formula in flowers, hurricanes, and galaxies. These echoes across scales are not exact copies, but they leave a statistical trace, a repeating rhythm detectable in numbers. It is as though the universe writes in a script of patterns, legible only when we slow down and compare. Now let us drift into a small thought experiment. Imagine standing in a forest, looking at the branches above. Step 1. We see the tree dividing into smaller and smaller limbs. Step 2. We imagine rising higher, looking down at a river basin where water carves branches across the land. The resemblance is clear, one in wood, the other in water. Step 3. We drift further outward, and galaxies too reveal branching filaments of stars, bound together by gravity. In this sequence, the mind notices a continuity, even though the scales are immeasurable. Whether the resemblance is coincidence or signal, we cannot say. But in the act of imagining, we sense an unbroken flow of form from the near to the infinite. The cautious conclusion is simple, and it rests without hurry. Patterns repeat across scales, sometimes for reasons we understand, sometimes for reasons still hidden. These repetitions do not prove that Earth is part of a larger organism, yet they soften the boundary between the small and the vast. They remind us that we live in a universe where shapes echo, where forms resonate, where familiarity appears in unexpected places. We leave this thought open, like a spiral still unfolding, without end and without final word. What if the Earth itself could be said to breathe, not with lungs or airways, but through vast cycles of motion and exchange that unfold quietly around us? When we step back and look at the planet as a whole, certain rhythms become clear. Winds circle the globe, carrying warmth and coolness from one region to another. Oceans swell and contract with tides, rising and falling as though moved by a gentle pulse. Forests absorb carbon during the day and release oxygen into the air, shaping the very mixture we depend upon. Each of these movements may appear separate, yet together they create something that resembles a breath, a steady in and out, a rhythm sustained over centuries. Now we pause for a moment on the atmosphere, the thin veil of gases that surrounds us. It may seem still, but in truth it is always moving. Air warmed by the equator rises, spreads outward, and drifts toward the poles, while cooler air returns. This circulation is like a slow exhalation and inhalation, redistributing heat across the planet. Scientists sometimes describe this process as a kind of engine, yet in a softer view it can be imagined as the planet's respiration. No one designed it so. It emerges from the simple fact that warm air rises and cold air sinks. The oceans too add their rhythm. Tides move under the pull of the moon, rising and falling with calm regularity. Waves carry energy across vast distances, transferring heat and stirring nutrient. Beneath the surface, deep currents cycle slowly, some taking hundreds of years to complete a circuit. In these vast flows, the ocean acts almost like blood in a body, carrying warmth and sustenance from one region to another. To us, it seems abstract, but to the planet it is constant motion, an inner circulation hidden under the surface. Forests and plants join this rhythm in their own quiet way. Through photosynthesis, they take in carbon dioxide and release oxygen, shaping the chemistry of the air. In the dark hours of night, this exchange reverses slightly, as respiration continues without sunlight. When seen together, the forests of Earth function almost like lungs spread across continents, drawing in and sending out gases that sustain the rest of life. Yet we must remain careful. The metaphor of breath is poetic, not literal. Earth does not breathe with intention, nor does it sense in the way animals do. What we observe are cycles, exchanges of matter and energy that resemble the act of breathing. Our language borrows from the familiar to describe what is vast. The resemblance may guide our imagination, but it does not prove that Earth is alive in the same sense that we are. Still, these rhythms leave traces we can study. Layers of ice capture bubbles of ancient air, showing us how gases have shifted over time. Rings in corals record changes in ocean temperature and chemistry. Even sediments at the bottom of lakes store pollen from vanished forests, whispering of past growth and decline. Each archive is a marker, a footprint of Earth's slow breath, recorded patiently across centuries. By piecing them together, we read the diary of planetary respiration. Let us imagine, gently, a small sequence of thought. Step 1. Picture the daily cycle. As sunlight warms the land, winds stir, plants open, and air exchanges gases. Step 2. Extend this view to centuries, where forests spread or shrink, oceans shift currents, and ice advances or recedes. Step 3. Move outward still further, and the rhythm stretches across millions of years, with cycles of oxygen rising and falling, climate warming and cooling. At every step, the breath grows slower, but the pulse remains. What appears to us as stillness is, at another scale, a living rhythm of change. The conclusion we reach here is not a claim of certainty, but a quiet recognition. Whether we describe it as breath or simply as cycles of physics and chemistry, the planet moves with patterns that resemble the rhythms of life. These patterns are not proof of Earth's awareness, yet they remind us that stability here is built from motion, and that silence is often filled with hidden circulation. In the gentle recognition of these flows, we can rest for a moment, aware of being carried within them, part of the same slow exhale and inhale that has shaped the world since long before we arrived. What if the Earth carried its own diary, written not in words but in stone, a record that stretches back far beyond the reach of memory? When we stand before a cliff or a canyon wall, we see lines and bands of color layered one upon another. These layers, which geologists call strata, are like pages that have been turned slowly by time. each one formed from grains of sand, particles of dust, shells of tiny organisms, all pressed together under weight until they became solid. To us, they appear unmoving, yet in truth they are frozen moments, archives of ancient climates and vanished seas. If we take time to look, we begin to sense that the planet has been quietly keeping its history all along. Now we pause for a moment on the way these records are made. A river floods and carries silt, depositing it as the waters recede. A desert wind blows dust across a plain, settling it in a thin layer. Over thousands of years, these small accumulations build thickness, like fine sheets of paper gathering into a book. When pressure and minerals bind them, they turn to stone. Within those stones are chemical clues locked away. Scientists study isotopes, which are slight variations of atoms, to understand what the air and water were like when the layer formed. In this way, a slab of rock becomes not only matter, but also memory. Yet we must acknowledge the limits of what we know. The Earth's diary is incomplete. Pages have been torn away by erosion, recycled through volcanoes, or buried deep beyond our reach. Sometimes entire chapters are missing, and the continuity is broken. We try to connect the fragments that remain, but gaps remain wide. Absence of evidence here does not mean absence of events, only that time has hidden them from our sight. Our picture of Earth's memory is therefore partial, a mosaic of glimpses rather than a full account. Still, the traces we have are enough to reveal great changes. In rocks we find layers rich with iron that tell of an atmosphere once without oxygen. We see bands of ash that mark ancient eruptions. We discover layers holding fossils of corals where now there are mountains, showing us that seas once covered them. Each of these details is a quiet marker, a footprint left without intention, preserved by chance and time. When pieced together, they whisper of shifts in climate, in life, in the planet's long rhythms. Now we gently enter a thought experiment. Imagine standing before a cliff face that holds 100 layers of stone. Step 1. Picture each band as a season, a flood, a storm, slowly pressed into permanence. Step 2. Imagine accelerating time, watching layers accumulate faster, the book of Earth growing thicker with each passing age. Step 3. Move forward millions of years, where our own traces, buildings, bones, even the dust of our industries, may be compressed into rock, becoming part of this diary. Future beings might see our presence as a thin stripe, a sudden and unusual mark among the quieter patterns of stone. Whether they interpret it as noise or as signal, it will remain a page in Earth's record. The conclusion that comes is gentle and open. Earth holds memory not in words, but in layers and minerals, in subtle variations recorded without design. These records are not perfect, but they remind us that the planet has its own way of keeping time, a patience measured not in hours or years but in ages. Whether we think of it as a diary or simply as geology, the effect is the same. The Earth remembers in silence. As we linger on this thought, we may rest with the awareness that we, too, are being written into that memory, slowly, quietly, without haste. What if the greatest signals of Earth's life were not loud or dramatic, but hidden in silence, carried by forces we do not see? When we stand on the ground, the air feels calm, the rocks steady, the sky quiet. Yet beneath this stillness, invisible fields and currents surround us, shaping conditions for life. The Earth's magnetic field, for example, extends far beyond the atmosphere. It cannot be touched directly, but it is there, a protective layer guiding charged particles away from the surface. Without it, solar winds, streams of energy from the sun, would strip the air and water over time. Instead, this invisible shield bends the streams aside, much like a soft barrier keeping us safe. In this quiet defense, we glimpse a quality that reminds us of skin, both boundary and protection. Now we pause briefly on how such a field arises. At Earth's core lies molten iron, moving in slow, swirling currents. These motions generate electricity, and the electricity creates magnetism. This process, called the geodynamo, is complex, yet the principle is simple. Moving metal can create a magnetic field, much like a wire carrying current around a loop. The result is an invisible structure stretching tens of thousands of kilometers into space. To us it is intangible, but its effects are constant, like a silent background presence. Though we understand much of this process, many uncertainties remain. The exact details of how flows in the core sustain the field are still debated. Sometimes the field weakens, sometimes it flips entirely, with north and south changing places. These reversals are recorded in volcanic rocks, where iron particles align with the direction of the field at the time they cooled. By studying these patterns, scientists see that flips have occurred many times, irregularly, over millions of years. Why they happen and what triggers them is not fully clear. The absence of certainty here is a reminder that even in long-studied systems, much remains hidden. Still, the traces are abundant. Rocks on the ocean floor carry stripes of magnetism, like a barcode, preserving the history of field reversals. Auroras near the poles shimmer when solar particles slip along field lines and strike the atmosphere. Satellites drifting above Earth record small changes in intensity, mapping how the field shifts year by year. These are not direct voices, but echoes, indirect signs of an ongoing process. The Earth does not announce its shield, yet it leaves behind a record for us to read. Now let us imagine a gentle sequence. Step 1. Picture the Earth without its magnetic field. Over time, the atmosphere thins, oceans fade, surface life weakens. Step 2. Imagine the field strengthening, extending further into space, bending solar winds more sharply, allowing life to flourish under steadier skies. Step 3. Think of reversals when the poles exchange roles. Compasses would point differently, animals that sense magnetism might adapt, and over centuries new alignments would settle. None of this happens suddenly, but in slow rhythms, almost beyond perception. The thought experiment leaves us with humility. The unseen holds great power. The conclusion is soft, without finality. Signals in silence surround us, in fields, in currents, in patterns that rarely meet the eye. They do not prove that Earth is alive in a conscious sense, but they remind us that even in stillness there is movement, even in silence there is protection. By paying attention to what is not immediately visible, we begin to sense the planet's quiet work, the unseen structures that hold us gently in place. And in that awareness we can rest, carried by shields we rarely notice, yet always inhabit. What if the balance we see around us, fragile and shifting, were the quiet equivalent of a body's effort to stay alive? In biology there is a word, homeostasis, which means the ability of a living being to keep its inner state within certain limits. Our bodies hold temperature, acidity, and pressure in steady ranges, even while the world around us changes. When we look at Earth, we notice something similar. For billions of years, despite meteors, eruptions, and shifts in orbit, the planet has kept conditions stable enough for life to endure. Not perfectly, not without crisis, but with enough balance to allow oceans to stay liquid, air to remain breathable, and ecosystems to recover after collapse. This balance is not a fixed state but a moving one, always adjusting. Now we pause on how this works in simple terms. The sun warms Earth, and the planet radiates heat back into space. If too much heat stayed, the planet would boil. If too little, it would freeze. Instead, gases in the atmosphere trap just enough warmth, creating a greenhouse effect that makes Earth habitable. Water too plays its part, evaporating, forming clouds, falling as rain, and circulating through rivers back to the sea. Forests, grasslands, and oceans absorb carbon dioxide, then release oxygen, shaping the chemistry of the air. Each of these loops adjusts itself slowly, like a thermostat, never perfect but always tending toward balance. Yet there are limits to what we know. The Earth's systems are vast and interlinked, with feedback loops that are difficult to predict. Sometimes a small change can be amplified. Melting ice reduces reflection of sunlight, warming the planet further. At other times, systems resist change. More carbon in the air may trigger more plant growth, drawing it down again. Our models can trace these processes, but they remain incomplete. The complexity of Earth's balance is such that certainty often escapes us. The absence of precise prediction is not evidence of chaos, only a reminder of how many variables lie hidden from view. The traces of these balances are preserved in archives across the world. In tree rings we see years of drought and plenty, showing how forests responded. In layers of sediment at the bottom of lakes, we find pollen, testifying to which plants thrived and which receded. In bubbles trapped in ancient ice, we read the concentration of gases in past atmospheres. Each archive is a soft signal of how Earth adjusted itself, sometimes gently, sometimes through abrupt shifts, but always within a range that allowed life to persist. Let us wander into a thought experiment. Step 1. Imagine a time when volcanic eruptions filled the skies with ash, dimming sunlight and cooling the planet. Life faltered but did not vanish, and in time the skies cleared. Step 2. Imagine the opposite, when warmth surged, melting glaciers and raising seas. Again life suffered, but new ecosystems formed in the changed climate. Step 3. Imagine Earth as a whole, adjusting over millions of years, not to preserve one species or another, but simply to maintain a state where processes continue. The balance is not designed, yet it endures, like a spinning top wobbling but rarely falling. The conclusion that arises is gentle. Earth's stability resembles the quiet persistence of living systems, though whether it is alive in that sense remains uncertain. What we can say is that balance here is not accidental but emergent, the result of countless processes entwined. By observing these traces, we learn that the planet holds itself within ranges that sustain us, though not forever, not without change. The awareness of this balance invites us to rest in humility, to see ourselves as part of a greater rhythm, steady yet fragile, enduring yet always in motion. What if the ground beneath us were not simply a stage for life but part of an intricate web, a vast network where every element is linked to another? When we step into a forest or walk across grasslands, it is easy to think of plants, animals, soils, and water as separate parts. Yet when we look closer, connections appear everywhere. Nutrients move from soil into roots, from roots into stems, from leaves into air. Animals feed on plants, return matter through waste, and eventually through their bodies. Nothing stands alone for long. Each action is tied into loops, weaving an invisible web that binds us all together. Now we pause gently on one thread of this web, the soil. It is not simply dirt but a living archive, filled with bacteria, fungi, and small creatures. These unseen partners decompose fallen leaves, recycle nutrients, and make them available again. Without them, forests would be buried under their own remains. Instead, the cycle continues, matter returning to soil and rising back into life. In this way, the ground itself behaves like a circulatory system, where flows are constant though rarely noticed. Above the ground, plants and animals mirror the same process. A tree gathers sunlight and water, creating sugars that feed not only itself but insects, birds, and larger animals. When those creatures die, their bodies return to the soil, closing the loop. Over time, countless generations move through these exchanges, their traces layered invisibly. The web grows thicker with every cycle, even if we cannot see the threads. Yet we must remain cautious. The metaphor of a web can suggest perfection, but in reality the system is fragile. Connections may break. An extinct species is a missing thread. A vanished forest is a torn patch in the fabric. The system adjusts, new links form, but the change leaves scars. We cannot claim that the Earth's web is flawless or unbreakable. What we can say is that interconnection is the rule, even if the details shift over time. The language of traces helps us see this more clearly. In sediments at the bottom of lakes, we find layers of pollen showing which plants once dominated. In shells preserved in soil, we see what waters once nourished. In chemical residues, we read what gases filled the air. Each record is indirect, a signal left behind by the web of life. By piecing together these archives, we see how the loops of exchange have held steady and how they have bent under change. Let us imagine, softly, a thought experiment. Step 1. Picture a single tree in a forest, its roots spreading underground. Now Step 2. Imagine that its roots meet the roots of others, linked by filaments of fungi. Nutrients pass from one tree to another, not as competition but as exchange. Step 3. Expand the view to the whole forest, where sunlight, rain, soil, and air all cycle endlessly, and where every being, large or small, participates. The forest becomes less an assembly of individuals and more a network, pulsing with flows. In this vision, Earth itself begins to resemble a single vast organism, though whether it truly is remains an open question. The conclusion here is not a final answer but a gentle reminder. Life does not move in isolation. It weaves, circulates, and returns. The web is fragile and incomplete, yet its presence is undeniable. By tracing the signals left in soils, sediments, and archives, we learn that connection is the quiet foundation of endurance. Whether or not we call Earth a larger organism, it moves with the logic of interdependence. In this awareness, we may pause, resting in the thought that to exist is already to be part of the weave, a thread in the planet's long and silent tapestry. What if time itself flowed through Earth not as a straight line but as a rhythm, a slow circulation that repeats in ways we can barely see? We often think of time as moving forward without return, yet the planet shows us something different. Ice sheets grow and retreat, oceans rise and fall, continents drift apart and later converge. These motions do not occur in days or years but in spans so long they escape ordinary sense. They are like a hidden pulse, slower than a heartbeat, steadier than breath, yet always present. When we look closely, Earth seems less like a clock and more like a tide, moving in vast cycles. Now we pause for a moment on one such cycle, the advance and retreat of ice. Over the past million years, glaciers have spread across continents, then melted back again and again. These ice ages occur roughly every 100,000 years, linked to subtle changes in Earth's orbit and tilt. A small variation in sunlight can trigger massive transformations, cooling seas, lowering forests, reshaping landscape. The glaciers withdraw, the warmth returns, and the rhythm begins again. It is not predictable like a metronome, but it is regular enough to mark the long breath of the planet. Oceans, too, carry cycles. Currents shift on scales of centuries, distributing heat across the globe. Sometimes they slow, sometimes they surge, altering climate in quiet but powerful ways. Even the chemistry of seawater changes, recording cycles of carbon and nutrients that move between air, water, and rock. In these motions, the oceans behave almost like a bloodstream, circulating slowly but persistently, carrying memory of past states in their depth. Yet our knowledge of these long rhythms is limited. We cannot watch them unfold directly. Human lifetimes are too brief. Instead, we turn to archives, ice cores, sediments, fossil records. Each holds traces of past climates, small signals of great shift. Oxygen isotopes in shells tell us how cold the oceans once were. Layers of dust and ice reveal when winds blew stronger across dry plains. The evidence is indirect, often incomplete, and our interpretations carry uncertainty. The absence of clarity does not mean absence of rhythm, only that our hearing of Earth's pulse is faint. Still, these faint traces build patterns when seen together. They show us that time on Earth is not uniform but cyclical, moving in loop. Now let us drift into a gentle thought experiment. Step 1. Imagine standing in a landscape where glaciers cover the ground, the air colder, the seas lower. Step 2. Allow the ice to melt over thousands of years, forests spreading northward, seas filling coastlines once dry. Step 3. Move further ahead as the cycle turns again and ice returns, repeating the pattern in silence. To us it is unimaginable slowness, but to the planet it may be a natural rhythm, steady as breath. The cautious conclusion is soft. Earth moves through time in cycles, not with intention, but through the interplay of orbit, sunlight, water, and rock. These cycles sustain, disrupt, and reshape, yet they return in patterns that remind us of a pulse. Whether this pulse belongs to a living being or simply to physics is uncertain. What is clear is that Earth does not drift randomly. It circulates through ages, holding memory in layers and rhythm in motion. In resting with this awareness, we sense that we too are carried within these long cycles, a brief moment in the planet's slow heartbeat. What if the Earth were speaking to us all the time, not in words but in faint shifts, in subtle patterns, in whispers too quiet to hear without careful attention? Much of what happens on our planet leaves no obvious trace in daily life. The ground seems firm, the seasons predictable, the skies familiar. Yet beneath this apparent calm, small variations occur. Temperatures drift by fractions, magnetic fields fluctuate, the length of a day alters by milliseconds. These changes are not easily felt, but they are measurable. And when measured over years, they begin to form a kind of language, a record of the planet's quiet state. Now we pause gently on one example, the Earth's rotation. To us, a day is steady, but in reality the length of a day is not fixed. It shifts slightly due to tides, winds, even movements deep in the core. Scientists use precise clocks and satellites to detect these tiny changes. Though the variations are small, they reveal that the planet is not a perfect machine but a body in motion, influenced by countless factors. It is as though the Earth sighs, not regularly but in subtle pauses. Another signal is found in climate fluctuations. Temperatures rise and fall not only over centuries but also from year to year. El Niño, for instance, is a warming of the Pacific Ocean that alters weather across the globe. Its partner, La Niña, brings cooling. These oscillations are like shifts in mood, gentle but widespread. They leave traces in rainfall, in harvests, in coral growth. Each oscillation is temporary, yet together they shape the rhythm of decades. Still, our knowledge is far from complete. We do not fully understand why some cycles begin or how long they will last. Sometimes our models predict well, and sometimes they fail. The Earth does not reveal all its signals and patterns we can decode easily. The absence of clarity does not mean there is no meaning, only that the language remains partly hidden. We continue to listen, refining our instruments, comparing archives, layering data upon data in the hope of catching the faintest whispers. Now let us linger for a moment on how these whispers are recorded. Ice cores preserve not only air but also traces of volcanic ash, telling us when eruptions darken skies. Tree rings capture wet and dry years, showing the rhythm of rainfall. Even sediments in seas carry layers of dust from deserts far away, marking shifts in wind. These archives are like notebooks scattered across the planet, each keeping a local record of global murmurs. When pieced together, they reveal conversations too vast for any single witness. We might imagine, softly, a thought experiment. Step 1. Picture a scientist recording the length of a day, noting a fraction of a second's change. Alone, it seems trivial. Step 2. Imagine centuries of such records layered into a timeline. The trivial becomes a pattern, showing tides pulling, winds shifting, cores moving. Step 3. Extend the view to millennia, where records from rocks, ice, and sediments join together. Suddenly, the Earth's whispers form a story, not of noise but of continuity. The small signals, gathered patiently, become a map of the planet's hidden life. The conclusion here is modest. The Earth may not speak in the way we do, yet it leaves signs, faint but enduring. To hear them, we must slow down, extend our view, and accept uncertainty. These signals do not prove that Earth is alive in a conscious sense, but they show us that silence is never empty. In stillness there are rhythms, in quiet there are traces. And when we notice them, gently, without hurry, we become part of the listening, part of the long dialogue unfolding between the planet and time itself. What if the clearest way to see Earth as a whole were to step far enough back that all boundaries dissolved into a single sphere of light and shadow? From space, the planet no longer shows its details, not the forests, the deserts, the rivers, but instead presents itself as one unified body. Clouds drift slowly across oceans, storms swirl in vast spirals, night and day divide the globe with a moving line. For those who first saw it from orbit, the impression was not of parts but of wholeness, a fragile roundness floating in darkness. In that view, Earth is not a map of countries, not a patchwork of regions, but a complete, breathing presence. Now we pause for a moment on how this image reaches us. Satellites circle endlessly, capturing the planet in motion. Some track temperature, others follow winds, others measure the faint glow of reflected light. These instruments give us records that stretch beyond the human eye, showing Earth as it changes hour by hour, season by season. The data are vast, yet their essence is simple. From a distance, the Earth reveals itself as one system. When we watch storms spiral, we see air moving as a whole. When we trace ocean currents, we see water flowing across basins without borders. This perspective shifts our sense of scale, reminding us that local events are threads in a larger weave. Yet we must acknowledge what we cannot know from above. A satellite shows patterns but not always causes. It captures surface light but not the inner motions of soil or root. The view is unifying, but it can also smooth over details that matter deeply. From space, deserts and grasslands appear alike. From space, a forest in decline may look as green as one that thrives. The absence of visible difference does not mean absence of change. Our interpretations must therefore be cautious, balancing awe with precision. Still, the language of these images is powerful. We see city lights spreading like constellations, their glow recorded night after night. We see ice retreating at the poles, captured as lines that shift on map. We see smoke from fires, long trails carried by wind across oceans. These are not just pictures but records, indirect signals of human presence, of natural rhythms, of planetary adjustment. When assembled into archives, they become a diary of Earth's surface, seen not from within but from afar. Let us imagine, gently, a thought experiment. Step 1. We rise just beyond the atmosphere, seeing Earth as a marble of blues, whites, and browns. The sense is of beauty, fragile and whole. Step 2. We drift further, watching it rotate, storms forming and fading, night following day. The sense now is of rhythm, steady and calm. Step 3. We move farther still, until the Earth is only a pale dot against darkness. Here, all details vanish, and only its unity remains. The impression is not of separate processes but of one luminous presence among countless others. Each step outward shifts our understanding, not by giving new facts but by changing perspective. The conclusion is quiet and open. The view from above does not prove that Earth is alive in the way an organism is, but it does remind us of its wholeness, its coherence. From space, the distinctions fade, and what remains is the image of a single entity, moving through time, carrying clouds, oceans, and lights together. This perspective does not solve the question of Earth's nature, yet it softens our vision, inviting us to see connection where we once saw separation. And in this softened view, we can rest, knowing that whatever Earth may be in truth, it is whole, and we are held within it. What if the Earth itself carried signs of growth, not in the quick span of years but across ages so long they stretch beyond imagination? When we look back into the deep past, we see that the planet has not remained the same. Its air, its seas, its very surface have transformed. Oxygen, once rare, became abundant. Continents that were once joined together drifted apart. Life that was once limited to oceans spread onto land. Each of these shifts resembles a stage of development, not unlike the way a living being grows, changes, and adapts through time. The difference lies only in pace. Earth's transformations unfold slowly across billions of years. Now let us pause for a moment on the air we breathe. In its earliest state, Earth's atmosphere was hostile to most of what we know as life today. It was filled with gases like methane and ammonia, but lacked free oxygen. Over time, microscopic organisms began producing oxygen through photosynthesis, a process that turns light into chemical energy. Slowly, the air filled with this new gas. Rocks turned rusty red as iron reacted with oxygen, leaving a clear marker we can still see in ancient stone. This event, often called the Great Oxidation, changed the course of life forever. It is recorded not in words, but in the chemistry of the planet itself. We will return to this idea of chemical traces later, but for now we simply note how the atmosphere's transformation echoes the growth of a body learning to breathe. The surface of Earth has shifted too. Continents once clustered into a single landmass have drifted apart, carried by slow movements beneath the crust. This process, called plate tectonics, works like a conveyor belt, pushing land together, then pulling it apart. Mountains rise, oceans open, climates change. The scale is too vast for us to witness directly, yet the evidence is clear in matching coastlines, in fossil records found on opposite shores, in the ridges of the ocean floor. The shifting continents remind us of growth in another sense, the reshaping of a form, not fixed but evolving, always in motion. Life itself has mirrored these planetary changes. Early organisms lived in shallow seas, simple and small. Over millions of years, they adapted, expanded, and took on new forms. Fish became amphibians, amphibians became reptiles, and plants spread roots across land. Extinctions came and went, yet each crisis opened paths for renewal. This long unfolding resembles the growth of tissues, layers forming upon layers, sometimes breaking down, sometimes renewing in different patterns. Now we gently acknowledge what we cannot fully know. The reasons behind some of these great shifts remain uncertain. Why oxygen levels rose in sudden leaps, why some species flourished while others faded, why continents moved as they did, these questions are only partly answered. Absence of full explanation does not mean absence of cause. It only reminds us that the planet's history is more intricate than our current tools can unravel. Still, the language of traces guides us. Rusted rocks from billions of years ago show the rise of oxygen. Sediments reveal when seas were shallow or deep. Fossils capture moments of change, like the sudden appearance of shells, or the disappearance of great reptiles. Even isotopes, tiny variations in atoms, reveal temperatures of oceans long past. Each archive is a page in Earth's biography, written slowly but with care. Now let us imagine a thought experiment. Step 1. Picture Earth in its earliest stage, its air heavy with gases unfriendly to us, its seas barren of complex life. Step 2. Allow time to pass in millions of years, and imagine oxygen filling the skies, continents separating, green plants covering land. Step 3. Drift further still to a distant future where the planet may again transform, perhaps with new continents, new atmospheres, new forms of life. In this slow sequence, Earth appears less like an unchanging stone and more like a body growing, not with intention but with persistence. The conclusion we reach is gentle. Earth has altered itself, not through choice but through the interplay of matter, energy, and time. Its transformations resemble growth, though we cannot claim it is alive in the way we are. What we can say is that the planet's history shows continuity, adaptation, and change, written into its rocks, its air, its oceans. To rest with this thought is to see Earth not as static but as unfolding, a presence shaped by time, carrying us along in its long and patient development. What if the Earth itself moved with a pulse, not quick and noticeable like our own, but stretched across ages so vast they resemble the slow beat of something immense? When we look at our surroundings, time feels linear, one day after another, one year following the next. Yet the records stored in ice, stone, and fossilized life suggest that Earth has long rhythms, cycles that return again and again. These cycles are not measured in minutes or hours, but in tens of thousands, even millions of years. They shape climate, ecosystems, and the very conditions of survival. If we soften our gaze, the planet begins to resemble a being with a heartbeat too slow for us to hear directly. Now we pause on one of these long cycles, the rhythm of ice ages. Over the last million years, Earth has shifted repeatedly between colder and warmer period. Vast glaciers advanced, covering continents, then retreated, leaving valleys carved by ice. Each cycle lasted about 100,000 years, guided by small changes in Earth's orbit and tilt. These changes altered how sunlight reached the planet, and with that, climates across the world transformed. The record of these pulses lies in sediments and ice cores, where traces of ancient air and dust mark the timing of each glacial advance and retreat. To us, these changes are unimaginable in scale, but to the Earth they may be as natural as an inhale and an exhale. Oceans too hold their own slow rhythm. Currents deep beneath the surface take centuries to complete their journeys, carrying heat and nutrients around the globe. When these currents weaken or strengthen, climates shift, affecting rainfall, storms, and even the spread of life. Traces of these changes remain in corals, in the chemistry of sediments, in the shells of plankton preserved on the ocean floor. Each record is a quiet mark of a pulse too slow for us to feel, but steady enough to guide the balance of life over ages. Yet we must admit our limit. We cannot hear the pulse directly, nor can we predict its every shift. Our instruments measure, but they also simplify. Records are broken, incomplete, sometimes erased by erosion or buried too deep to reach. The patterns we find are real, but not always regular, not always predictable. The absence of certainty does not mean there is no rhythm, only that the beat is quieter than our listening. Still, the traces are enough to reveal continuity. Ice layers hold bubbles of air that show swings in carbon dioxide. Ocean sediments reveal cycles of warming and cooling. Fossil pollen shows forests advancing and retreating with climate. Together, these signals form a soft map of Earth's long pulse, repeating across generations. Let us imagine, gently, a thought experiment. Step 1. We picture ourselves standing in a glacial valley, the marks of ice still visible though the glacier itself has vanished. Step 2. We move back in time and see ice slowly advancing, grinding mountains, spreading across plains. Step 3. We move forward instead, imagining forests regrowing, animals returning, seas rising again. Each step is part of the same slow beat, a cycle far larger than us, yet carrying us within it. The conclusion we reach is not absolute but tentative, resting in humility. Earth's long rhythms resemble a pulse, though whether this is truly life or only physics remains uncertain. What is clear is that the planet does not drift aimlessly. It moves through cycles, each leaving quiet traces in ice, rock, and soil. These traces remind us that even when time feels linear to us, Earth carries within it a deeper heartbeat, one that spans ages. To notice this heartbeat is to sense our place within it, a brief moment, carried softly in the long rhythm of the world. What if the turning points in Earth's story were written not by steady rhythms but by sudden accidents, quiet at first yet shaping everything that followed? When we think of life and planets, we often imagine smooth progress, cycles repeating with calm regularity. But history also holds disruptions, impacts, eruptions, shifts that arrive without warning. These moments, though brief compared to deep time, leave traces as enduring as any long rhythm. They remind us that chance, too, has a place in the unfolding of the planet. Now we pause for a moment on one such accident, the fall of a meteor long ago. About 65 million years in the past, a large asteroid struck near what is now the Yucatan Peninsula. The impact released energy beyond any human scale, darkened the skies with dust, and ended the age of the great reptiles. Yet in the same event, space was opened for mammals to flourish, eventually leading to us. The mark of that impact is not only in fossils but also in a thin layer of clay, rich in iridium, a metal rare on Earth but common in asteroid. This thin band in rock strata is the quiet signature of a sudden disruption. Volcanoes too have written their chapters. When they erupt with unusual force, they cast ash high into the atmosphere, cooling the planet for years. Ancient eruptions left layers of basalt across continents, vast sheets of dark rock we can still walk upon today. These events reshaped climate, altered oceans, and transformed ecosystems. They were moments of upheaval, yet they left enduring records in stone, a reminder that the Earth's balance is sometimes nudged by bursts of fire. Even the tilt of Earth's axis, which gives us seasons, is itself a kind of accident. Long ago, a collision with another body may have tipped the planet, creating cycles of warmth and cold that life has since adapted to. Without that tilt, climates would be starkly different. The Moon, born from that same collision, has since steadied the tilt, helping Earth remain within ranges where life can persist. Here again, chance left not only scars but also stabilizers, as though disorder and order walk together. Yet we must hold our knowledge gently. We cannot always trace every cause, nor know every effect. Sometimes the evidence is ambiguous, sometimes missing. A gap in fossils may suggest extinction, but the exact trigger remains unclear. A sudden cooling in sediments may point to eruption, or impact, or some other chain of event. The absence of certainty does not mean absence of meaning. It only reminds us that Earth's accidents are often complex, woven from several threads at once. Still, the language of traces helps us piece together the story. In rocks, we find shocked quartz, crystals fractured by immense pressure. In ice, we find ash layers marking volcanic winters. In sediments, we find sudden shifts in pollen, showing forests that collapsed quickly, replaced by new growth. These indirect signs are like footprints left after the fact, allowing us to infer what passed even if we cannot witness it directly. Now let us wander through a thought experiment. Step 1. Imagine Earth untouched by accidents, its orbit stable, its skies calm. Life might have continued in different directions, perhaps without mammals, perhaps without us. Step 2. Reintroduce the meteor, the eruption, the tilt. The story bends, ecosystems reset, new paths open. Step 3. Move forward millions of years, where other accidents may still come, shifting the course again. In this view, chance becomes part of the planet's long dialogue, not an interruption but another kind of rhythm, irregular yet essential. The conclusion is soft and without finality. Earth's history is not only steady cycles but also sudden turns, shaped by chance events that leave lasting echoes. Whether we see these as random or as threads in a larger pattern remains uncertain. What is clear is that the planet carries both regularity and surprise, both long pulses and sharp break. To rest with this thought is to see Earth as more than predictable flow. It is also a canvas where accidents leave enduring marks, reminders of how fragile and yet how resilient the fabric of life can be. What if Earth were not wandering alone but moving within a family, bound together by invisible threads of gravity and time? When we think of our planet, it is natural to focus inward, on its forests, oceans, and skies. Yet when we step back into the scale of the solar system, we see that Earth is one among many companions orbiting a shared star. Mars, Venus, Jupiter, and others drift with us, each following its path, each exchanging subtle influences. In this wider view, Earth becomes part of a neighborhood, not an island but a member of a group whose interactions leave quiet traces across deep time. Now we pause for a moment on the nature of this family. The Sun anchors it, its mass pulling all planets into orbit. Gravity here is both bond and guide, keeping the planets moving in loops that repeat endlessly. Yet the paths are not fixed like tracks, they shift slowly, tugged by one another's presence. Jupiter, vast and heavy, slightly alters Earth's orbit. Venus and Mars exert smaller pulls. Even tiny bodies, asteroids and comets, sometimes cross Earth's path, leaving impacts or traces of dust. The system is not rigid but dynamic, each member contributing to the subtle balance. We must acknowledge, however, that much of this interaction remains beyond our direct perception. The orbits are measured, but the long-term consequences are uncertain. Some cycles stretch over tens of thousands of years, others over millions. Predictions can be made with mathematics, but the further we look ahead, the less precise they become. Small uncertainties in initial conditions grow into larger uncertainties with time. The absence of exact foresight does not mean chaos, only that the system is more intricate than we can fully calculate. Still, the language of traces helps us glimpse the patterns. In ancient rocks we find layers enriched with tiny grains from meteor showers, telling us that Earth has long crossed paths with streams of cosmic dust. In craters we see scars of impacts, reminders of moments when the neighborhood grew too close. Even in fossils, sudden disappearances sometimes coincide with cosmic events, hinting at the quiet but lasting influence of planetary siblings and wandering visitors. These records are indirect, but together they remind us that Earth's history is not shaped only from within but also from without. Let us now drift into a thought experiment. Step 1. Imagine Earth without its neighbors, circling the Sun alone. Without Jupiter's pull, comets might wander more freely, some striking Earth more often. Without the Moon, itself likely born of a collision, our tides would be faint, our tilt less stable, our climates more erratic. Step 2. Imagine Earth within its actual neighborhood, the Moon steadying our tilt, Jupiter deflecting or capturing comets, Venus and Mars sharing gravitational dances. The balance becomes more intricate, less random. Step 3. Move further still, to the galactic scale, where the solar system itself circles the center of the galaxy, joined by billions of other stars. Earth is a member not only of a planetary family but of larger families, each nested within another. The quiet conclusion is not one of certainty but of perspective. Earth is not solitary. It belongs to a network of neighbors, bound by gravity, influenced by encounters, carrying traces of these interactions in stone and memory. Whether we see this as a cosmic family or simply as physics, the result is the same. Earth is part of something larger, a member of a system that endures across deep time. Resting in this thought, we can soften our sense of isolation, remembering that our planet drifts not alone but accompanied, held gently in a web of orbits and cycles that continue whether we notice them or not. What if the most important structures of the universe were the ones we cannot see, networks hidden beneath the surface, binding what seems separate into quiet unity? On Earth, such networks exist just below our feet. Roots stretch outward from trees, meeting roots of others, linked by thin filaments of fungi. Through these filaments, nutrients and signals travel, allowing one tree to share with another, even across distance. Scientists sometimes call this the wood wide web, though in truth it is not designed but grown, a slow weaving of soil, root, and fungus. It is a reminder that what sustains the visible is often hidden. Now we pause gently on how such a network works. Fungi thread themselves through soil like delicate strings, attaching to root. In exchange for sugars made by the tree, they bring minerals and water gathered from further away. When several trees connect, the fungi form bridges, and what was once isolated becomes a community. Signals too pass along these threads, subtle chemical messages that prepare neighbors for drought or pest. It is not communication as we know it, but it is coordination, an invisible system beneath the visible forest. The Earth holds larger hidden networks too. Rivers run below ground, unseen aquifers storing water that resurfaces far away. Magnetic fields extend above us, invisible lines shaping how particles move. Even in the cosmos, galaxies cluster not at random but along filaments of dark matter, threads that hold stars and gas in quiet scaffolds. Though we cannot see dark matter directly, its pull bends light from distant galaxies, leaving a measurable signature. The unseen shapes the seen, across scales. Still, we must be cautious. Much of this remains uncertain. We cannot follow every root thread, nor trace every fungal signal. We cannot detect dark matter except through its effects, and even then our models are incomplete. The absence of direct evidence does not mean these networks are illusions. It means our perception has limits. We infer the presence of connections by their marks, not by seeing them outright. Traces are the language we rely on. Fossilized roots leave impressions in ancient soils, showing that networks existed long before us. Layers of minerals reveal how underground waters shifted over time. Maps of galaxies reveal a pattern like lace, stars arranged in filaments that echo unseen frameworks. Each of these is indirect, yet together they suggest a theme. Connection lies beneath the surface, shaping what endures. Let us imagine, softly, a thought experiment. Step 1. We picture a forest from above, each tree standing apart, crowns not touching. It looks like a gathering of individuals. Step 2. We lower our gaze beneath the soil and see threads linking tree to tree, resources flowing in hidden pathways, the forest less an assembly and more a single system. Step 3. We move outward into space, and galaxies too seem separate, scattered across darkness. Yet when mapped, they form filaments bound by gravity, part of a greater structure. The view shifts, the separate becomes woven. The quiet conclusion is gentle. Hidden networks exist everywhere, binding what looks apart into soft unity. Whether in soil, in water, or in cosmic scales, the unseen leaves traces that guide our understanding. These networks do not prove that Earth or the universe itself is alive, but they soften the boundary between part and whole. To notice them is to sense that we dwell not in isolation but within webs, sustained by connections too fine for ordinary sight. In this awareness we may rest, held within threads we rarely see, yet always live inside. What if the earth itself carried scars and memories in its very shape, as though its surface were skin that has healed from countless events? When we look at the land, it seems solid, enduring, but in truth it has been molded again and again by forces both gentle and violent. Mountains rise, rivers carve valleys, seas retreat, leaving layers of stone. Each change leaves a mark, a record of what once was. Over time, these marks overlap, creating a palimpsest, a manuscript written and rewritten, never fully erasing the lines beneath. Now we pause for a moment on mountains. They appear eternal, yet they are born from collisions of continents, when plates of Earth's crust press against each other. Rock folds, breaks, and lifts upward. In those folds we see the memory of ancient seas, shells pressed into stone high above where water once lay. Later, wind and rain slowly grind the peaks down, scattering the fragments into rivers and plains. The mountain is both rising and falling at once, a reminder that every feature we see is part of a longer story. Valleys too are records. A glacier sliding over land scrapes stone smooth, leaving behind U-shaped valleys when it melts. A river winding for centuries cuts a narrower, V-shaped path, its curves remembering the flow of water through ages. Desert winds shift sand, creating dunes that migrate across landscapes, their ridges holding the memory of storms. Each form is not just landscape but evidence, a quiet witness to motion that has already passed. Yet we must accept limits in our knowledge. The planet's surface has been reshaped many times, and older marks are often erased by newer ones. Continents that existed billions of years ago may have left only fragments. Shorelines of vanished seas are hidden under layers of later deposit. Our maps of ancient Earth are reconstructions, careful but incomplete. The absence of detail does not mean absence of history, only that time has hidden it. Still, the language of traces gives us clues. In rocks we find ripple marks, frozen waves of sand that show where shallow water once moved. In cliffs we see tilted strata, reminders of tectonic upheaval. In the chemistry of minerals, We detect pressures and temperatures that tell us how deep a stone once lay before being lifted. These small details are like handwriting, signatures of events too slow for us to witness directly. Let us imagine, gently, a thought experiment. Step 1. We picture Earth as it might have been 3 billion years ago, its surface mostly ocean, with small volcanic islands breaking the water. Step 2. We let time pass, continents forming, colliding, mountains rising where seas once spread. Forests grow, deserts appear, ice advances and retreats, each stage leaving its marks. Step 3. We move forward again, millions of years ahead, where new collisions will lift fresh mountains and current coastlines will be buried. The surface we know now will be remembered only in fragments, its outlines blurred into the next version of the planet. The conclusion here is gentle and open. Earth's surface is not fixed but shaped by memory, by the accumulation of marks from processes that continue endlessly. Whether we think of these marks as scars or as stories, they remind us that the ground beneath us has lived many lives. We cannot read all of them clearly, but enough remains to show us that change is the constant and memory is written not only in archives we dig from ice or sediment, but in the very forms of mountains, valleys, and plains. To rest in this thought is to feel time stretch, and to sense that we walk across a surface that remembers far more than we can know, holding us quietly as part of its unfolding story. What if the energy that flows through Earth were not only a resource but also a sign of circulation, a quiet reminder that the planet is never still inside? When we stand on the surface, the ground feels firm, as if it has always been the same. Yet deep below, heat moves slowly outward, rising from the molten core through layers of rock, feeding volcanoes, warming oceans, driving the slow drift of continents. This steady release of energy is not chaotic but patterned, much like warmth radiating from a living body. If we take time to notice, the planet reveals itself as full of movement, guided by its inner fire. Now we pause for a moment on the source of this heat. Part of it is leftover energy from Earth's birth, when collisions of rock and metal created enormous temperatures. Another part comes from the decay of radioactive elements, tiny atoms breaking apart and releasing heat. This process is constant, like a clock that ticks invisibly in stone. Together, these sources keep the core molten and the mantle in motion, producing convection, slow currents of rock rising and sinking. Though invisible to us, these motions push continents, open oceans, and lift mountains, reshaping the surface across millions of years. Yet our understanding is limited. We cannot journey to the core, we can only infer its nature through indirect signs. Seismic waves from earthquakes bend and reflect differently depending on the materials they pass through, giving us an outline of inner layers. Heat flow measured at the surface shows us where energy escapes more strongly. Volcanic rocks carry chemical signatures of deep origins, but many details remain uncertain. How currents twist, how stable they are, whether sudden changes ripple upward. The absence of direct observation does not mean absence of truth, only that Earth keeps much of its inner life hidden. Still, the language of traces is clear enough to guide us. Chains of volcanoes mark zones where plates sink back into the mantle. Mid-ocean ridges reveal places where new crust is created, warm rock rising from below. Even the shape of continents, their drift recorded over time, is a marker of deep circulation. These features are the outward expressions of an inner process, quiet but enduring, a pulse that reshapes the world slowly but without pause. Let us imagine, softly, a thought experiment. Step 1. Picture Earth without its inner heat, the core cooled, the mantle still. Continents would cease to drift, mountains would stop rising, volcanoes would fall silent. The surface would become static, weathered only by wind and water. Step 2. Imagine Earth as it is now, with energy moving upward, continents shifting a few centimeters each year. In our lifetimes it feels invisible, yet over millions of years oceans open, lands collide, climates shift. Step 3. Move far ahead in time, where the core has cooled more, the energy diminished. Earth then would look quieter, less reshaped, its surface more stable, but also less renewing. In this sequence, we see how inner fire sustains the planet's continual transformation. The conclusion that comes is not definitive but calm. The flow of heat inside Earth resembles a kind of metabolism, not alive in the way our bodies are, but persistent, sustaining cycles of renewal. Whether we interpret this as evidence of life or only as physics is uncertain. What we can say is that energy moves, circulates, and leaves lasting marks on the surface, shaping the world we inhabit. To notice this is to feel that stillness is an illusion, that beneath every step we take lies motion too slow for us to sense, but steady enough to carry the planet through ages. And in this awareness we can pause, resting in the thought that the ground beneath us is not silent but gently alive with hidden flow. What if the winds and waters of Earth were not only weather but also signals, carrying messages across the surface in ways that resemble circulation in a body? When we notice a breeze, it feels like a passing moment, but behind it lies a vast system of air currents linking continents. When we see waves, they seem local, yet beneath them are ocean streams that take centuries to complete their loops. Together, these movements create a global exchange of heat, moisture, and energy. They bind regions together, so that what begins in one place often ends far away. Now we pause gently on the atmosphere. Warm air near the equator rises, spreading toward the poles, while cooler air sinks and returns. This simple motion, driven by the sun's uneven heating, gives rise to winds that circle the globe. Storms are born where energies meet, carrying moisture across thousands of kilometers. To us, clouds seem fleeting, but they are part of a continuous conveyor, always moving, never at rest. The oceans mirror this process, though more slowly. Surface currents, pushed by winds, form gyres, great circular flows like turning wheels. Beneath them, deep currents move under the force of density differences in water, guided by temperature and salt. Together, they form what scientists call the global conveyor belt, a circulation that connects all seas into one. Water that sinks in the North Atlantic may not rise again for centuries, yet when it does, it brings with it the memory of its journey. The Earth, in this sense, circulates as much as it rotates. Yet we must acknowledge the limits of what we know. Weather is notoriously difficult to predict beyond short spans. Ocean currents, too, can shift in ways our models do not always foresee. Feedback loops complicate the picture. Ice melts, fresh water enters the sea, currents weaken, climates shift. The absence of perfect prediction does not mean absence of order. It only reminds us that complexity creates patterns we are still learning to read. Still, the traces of circulation leave record. In tree rings, we see years of drought and abundance, shaped by winds that carried or withheld rain. In corals, we read temperatures of past seas, reflecting the rhythm of current. In sediments, we find layers of dust from deserts carried across oceans, marking the breath of global wind. Even in ice cores, salts and volcanic ash reveal the reach of distant storms. Each of these is a fragment of Earth's weathered diary, written not in words but in cycles of movement. Let us imagine, softly, a thought experiment. Step 1. Picture a world without circulation, where winds stand still and oceans rest. Heat would build unevenly, deserts would spread wider, and seas would stagnate. Life as we know it would falter. Step 2. Imagine the world as it is, with constant circulation. Warmth from the equator drifts outward, cold from the poles sinks inward, oceans mix, clouds travel. Balance is never perfect, but it is always in motion. Step 3. Imagine subtle changes in this circulation as ice melts or heat increases. The loops might weaken or shift, altering climates across continents. A dry region may grow wetter, a fertile land may become parched. The planet adjusts, but not always in ways we can predict. The conclusion is soft and without finality. Earth's atmosphere and oceans act as a circulatory system, moving energy and matter across scales too large to see directly. Whether we interpret this as lifelike or purely physical, the effect is the same: a global flow that sustains balance. In these winds and currents, we find a rhythm that is steady yet fragile, dependable yet shifting. To rest in this thought is to sense that every breeze, every tide, is part of a larger pulse, a quiet movement that joins all regions into one body of motion. What if Earth's memory was not only written in rocks or ice but also carried by sound and vibration, subtle resonances that move through air, water, and stone? We often think of the planet as silent, but in truth it is never quiet. Winds whistle across mountains, waves strike coasts, glaciers crack, and even deep within, earthquakes send ripples through the crust. These vibrations are not random; they follow patterns, echoing through the earth like faint notes of a vast instrument. If we pause to listen, we find that the planet has its own low music, rhythms too deep for our ears but recorded by instruments with patience. Now we linger on how this works. When an earthquake strikes, it releases energy that travels in waves through the ground. These waves move like ripples across water, except they pass through stone, circling the globe many times before fading. Sensitive devices called seismographs capture them, showing us how the earth rings after a tremor. In fact, even without earthquakes, the earth vibrates gently all the time, stirred by winds, tides, and ocean waves. This faint background hum is called the Earth's free oscillation. It is so soft we cannot feel it directly, yet it is constant, like the planet's quiet breathing. Sound travels through water as well. Whales sing across oceans, their calls carried thousands of kilometers, bouncing within the sea like echoes in a cave. These natural songs tell us not only about life, but also about the ocean itself. Changes in sound speed reveal changes in temperature and depth, allowing us to sense shifts in climate by listening to the seas. In this way, the planet's voice is both biological and physical, woven together. Yet there are limits to what we know. We cannot capture every sound, and many vibrations are lost before we detect them. Some signals overlap, making it hard to tell one source from another. The deep hum of the planet remains partly mysterious, its origins not fully explained. The absence of clarity does not mean silence. It only means that our hearing is incomplete. The language of traces still helps. Sediment layers near coasts hold patterns of ancient storms, their strength recorded in sand pushed far inland. Coral reefs preserve the echoes of waves in their growth lines. Even stalagmites in caves contain subtle records of dripping water, the rhythm of past rains locked into mineral rings. These are sound translated into matter, vibrations turned into archives we can read long after the original noise has faded. Let us imagine, softly, a thought experiment. Step 1. Picture Earth struck by a large earthquake. For hours, even days, the planet vibrates, waves circling, fading, circling again, like the lingering note of a bell. Step 2. Picture the oceans alive with sound, whales calling, storms roaring, ships humming. Each sound adds to a chorus that fills the water, carrying information across vast distances. Step 3. Imagine far into the future, when these sounds are gone but their imprints remain, in coral, in sand, in records stored by instruments. Earth's hum continues, whether heard or not, a low background of presence. The conclusion is gentle and open. Earth vibrates with sound and motion, not in the way a conscious being sings, but in the way a body resonates simply because it exists. These vibrations remind us that silence is an illusion. Beneath stillness there is always movement, always resonance. Whether we call it music or merely physics, the effect is the same: a planet alive with hidden rhythm. To rest with this thought is to sense ourselves within that rhythm, carried by vibrations that began long before us and will continue long after, part of Earth's quiet song to itself. What if Earth, like any intricate being, had ways of repairing itself, slow processes that counterbalance disruptions and guide it back toward equilibrium? We often think of balance as fragile, easily broken, But the planet holds a remarkable capacity for adjustment. Not perfect, not immediate, but steady. Carbon absorbed by forests and oceans, heat distributed by winds and currents, nutrients recycled by soils, all are part of this quiet resilience. If we linger for a moment, the Earth begins to resemble a system with its own healing rhythms. Now we pause gently on one such rhythm, the carbon cycle. Plants absorb carbon dioxide from the air during photosynthesis, using sunlight to form sugars. When they die, part of that carbon returns to the soil, some locked into sediments, some released again. Oceans, too, draw carbon into their waters, storing it for centuries in currents and even longer in limestone. These processes are not quick, but over ages they soften spikes, smoothing the extremes. In this way, Earth regulates its own air, though never without fluctuation. Water also plays its part. When rains wash nutrients into rivers, the sea collects them, circulating them through plankton, fish, and back again into sediments. Later, tectonic forces lift those sediments, and erosion returns them to land. What seems lost is eventually restored, though the cycle may take millions of years. This recycling, like the slow healing of a wound, shows us that Earth endures by turning losses into future gains, even if the pace feels beyond our sight. Yet we must hold our understanding with care. Not all disruptions are absorbed easily. A sudden volcanic eruption may overwhelm the atmosphere with ash, cooling the planet abruptly. A large impact can change ecosystems in a single day. Human activity, too, introduces changes at a pace faster than many natural cycles can counter. The absence of instant repair does not mean absence of resilience, but it does remind us that balance has limits, and recovery is not always gentle. Still, the language of traces reveals Earth's attempts at healing. In ice cores, we see carbon levels rise and then slowly decline as forests regrew after ice ages. In rocks, we find layers of chalk built from ancient plankton blooms, a vast store of carbon pulled from the air. In soils, we see fertility restored after centuries of rest. These are not miracles, but processes, quiet and persistent, repairing what was strained. Let us imagine, softly, a thought experiment. Step 1. A great forest burns, filling the sky with smoke, its carbon returning to the air. Step 2. Over decades, seeds sprout, trees return, soil recovers. Slowly, the balance shifts again, the air cleansed by new leaves. Step 3. Extend this vision across millennia, with oceans drawing in excess gases, rocks storing them in limestone, and the planet gradually adjusting. The rhythm is long, but the intent seems clear, not to preserve what was, but to continue in altered form. The conclusion is gentle, open, and without certainty. Earth possesses resilience, mechanisms that resemble healing, though they do not always protect every species or every landscape. What they do is sustain continuity, keeping the planet habitable even after upheavals. Whether we call this healing or simply the unfolding of chemistry and physics does not matter as much as the recognition that Earth endures by rebalancing. To rest in this thought is to sense that we live within a system that is patient, one that repairs itself slowly but with persistence, carrying both its scars and its strength into the future. What if the patterns we see in life on Earth were not separate from the patterns of the planet itself, but expressions of a deeper unity, as though the biosphere and the geosphere were intertwined in a single fabric? When we look at forests, oceans, or deserts, it is tempting to think of them as additions placed upon the surface. Yet life does not simply rest on Earth. It shapes it, alters it, and is shaped in return. The soil beneath us is built from decayed plants and animals. The oxygen we breathe was once produced by tiny organisms in the sea. Even the colors of landscapes, green forests, golden fields, coral reefs, are the outcome of life's long conversation with stone, water, and air. If we pause gently here, we see Earth not as a stage for life, but as life's partner, bound together in a quiet dance. Now we linger on the simple mechanism of feedback. When plants grow, they draw carbon from the air, cooling the planet slightly. When they die in great numbers, that carbon returns, warming it again. Oceans, filled with plankton, perform a similar balancing act, locking carbon in shells that sink to the seafloor. Over time, these shells form limestone, rock built from the remains of life. Later, tectonic forces lift that rock, exposing it to air where it may weather, releasing carbon once more. In this cycle, life and geology fold into each other. Neither is fully separate, each adjusts the other. But our knowledge of this weaving is partial. Many of the details remain hidden. We do not fully understand how quickly feedbacks act, or how resilient they are to sudden change. Sometimes the balance seems steady, but then a tipping point appears, and conditions shift more sharply. The absence of full explanation does not mean absence of connection. It only means that the threads of Earth's fabric are finer than our tools can yet follow. Still, the traces left behind reveal the unity. Fossils in chalk cliffs show ancient seas once rich with microscopic life, their remains now towering as stone. Black shales record times when oceans held little oxygen, ecosystems collapsing and later reviving. Even in the thin air above us, we detect the isotopic fingerprints of plants, proof that the breath of forests circulates far from where the trees grow. Each record is an archive of exchange, the ongoing dialogue between life and the planet. Let us imagine, softly, a thought experiment. Step 1. Picture Earth without life, only rock, water, and air, the surface bare and inert. Step 2. Allow simple life to emerge, changing air chemistry, carving channels in stone, building reefs of calcium carbonate. Slowly, landscapes become co-created, shaped by both geology and biology. Step 3. Drift into the present, where every handful of soil, every breath of wind, every droplet of water carries traces of both living and non-living origins. The boundary between them is not sharp, but blurred into unity. The conclusion here is gentle, resting in humility. Earth and life cannot be cleanly separated. One forms the conditions, the other reshapes them, together sustaining cycles that endure across time. Whether we call this interdependence an organism or simply a system matters less than noticing how deeply bound they are. To pause with this thought is to sense that we, too, are part of the weave, one strand in a fabric where stone, air, water, and living presence have always belonged together. What if the patterns we call evolution were not only the story of species but also the expression of Earth itself, as though life were one of the ways the planet changes shape over time? When we look at fossils, when we trace family trees of organisms, it is easy to see a tale of adaptation and survival. Yet if we soften our view, these shifts resemble the slow unfolding of a single system, with life and planet woven into one another. The rise of forests altered the atmosphere. The growth of coral reefs reshaped coastlines. The spread of grasses transformed entire landscapes, changing the course of rivers and the habits of animals. Evolution is not separate from Earth. It is part of its long transformation. Now we pause for a moment on how this works. Evolution, in simple words, is change across generations. Small variations appear in living beings, and some are passed on if they help survival. Over long spans, these variations accumulate, creating new forms of life. But these changes do not happen in a vacuum. They are responses to shifts in climate, in geography, in the chemistry of air and sea. When the planet cools, species adapt or vanish. When oxygen rises, new metabolisms emerge. Earth and life move together, each adjusting the other. We must admit, however, that much remains uncertain. Fossil records are incomplete. Whole species may have lived without leaving a trace we can now find. DNA carries hints of ancestry, but only back so far. The absence of complete records does not mean the story is missing. It means it is partly hidden, as if written in fading ink. Our reconstructions are careful, yet always open to revision. The language of traces still speak. In layered rocks, we see sudden bursts of diversity, like the Cambrian explosion, when many forms appeared in a geologically short time. In isotopes, we detect the rise of oxygen, linked with the spread of new life. In the pollen locked in sediments, we see forests expanding and retreating with ice ages. Each trace is indirect, yet together they reveal the dialogue between planet and organisms, a dialogue that never truly stops. Let us imagine, softly, a thought experiment. Step 1. Picture Earth in its early state with life still simple, mostly microbial, its influence on the planet slight. Step 2. Imagine the spread of plants onto land, greening the continents, altering rainfall, deepening soils, changing the course of evolution for animals as well. Step 3. Drift forward to the present, where human presence, itself the outcome of evolution, reshapes Earth's surface, atmosphere, and waters. In each stage, life is both adapting to Earth and rewriting it in return. The conclusion is quiet and open. Evolution is not only the history of species, but also the history of Earth itself expressed through life. Whether we see this as the planet guiding its own changes or as a shared unfolding between matter and organism is uncertain. What is clear is that the two cannot be separated. To rest with this thought is to sense that the story of life is at once the story of the planet, and that we ourselves, however brief our moment, are part of this deep and ongoing transformation. What if intelligence were not confined to brains but expressed through larger systems, as though the planet itself carried forms of awareness too slow or too vast for us to recognize? When we speak of thought, we imagine neurons firing, signals passing across synapses in fractions of a second. Yet networks exist beyond us, patterns that gather, process, and respond in ways that resemble thinking. A forest adjusts to drought by redirecting resources underground. Oceans shift currents when warmed, changing climates across continents. Even the atmosphere redistributes heat, correcting imbalances with storms. None of these resemble our own intelligence directly, yet all show coordinated response. If we pause gently here, we can consider the possibility that Earth itself holds a quiet form of cognition, one that moves not in seconds but in centuries. Now we linger on how such processes might work. Intelligence, at its simplest, is the ability to sense, to respond, and to adapt. Earth clearly senses through its systems. Volcanoes relieve pressure, rivers carve new paths, ecosystems adjust to scarcity. Response comes through feedback loops. More heat brings more cloud cover, more growth brings more carbon stored in soils. Adaptation appears across ages, with species evolving to fill gaps and climates shifting to new equilibria. These are not thoughts in the human sense, but they echo the structure of thinking: input, change, outcome. Still, we must move carefully. To call Earth intelligent may stretch the term beyond its usual meaning. We cannot measure consciousness in rocks or clouds, nor can we detect intention in the motion of current. The absence of direct evidence does not mean absence of deeper order, but it does mean we must be modest in how we describe it. At most, we can speak of analogies, parallels that help us reflect, while leaving the question open. The language of traces gives us hints. In ice layers, we see climate swinging back and forth, not wildly, but within ranges that support life, as though guided by feedback. In sediments, we see shifts in ecosystems following great disruptions, balance re-emerging over time. Even in modern records, we see forests recovering after fires, soils rebuilding after flood. These signals suggest not control, but resilience, a pattern of response that resembles learning written into the planet's fabric. Let us imagine, softly, a thought experiment. Step 1. Picture a brain, neurons firing in pulses, creating awareness in seconds. Step 2. Picture Earth, systems pulsing in decades or millennia, glaciers advancing and retreating, forests spreading and shrinking, oceans circulating in loop. If we compress the timescale, the patterns resemble each other, not identical, but structurally similar. Step 3. Imagine Earth across millions of years, each disruption followed by adjustment, each collapse followed by renewal. Seen this way, the planet may appear as a kind of slow mind, one whose thoughts are written not in words, but in climates, landscapes, and ecosystems. The conclusion is soft and without certainty. We cannot prove that Earth thinks, nor can we deny the echoes between its patterns and our own. What we can say is that the planet responds, adapts, and endures, behaviors we often associate with intelligence. Whether this is truly thought or only the flow of physics remains open. To rest with this thought is to recognize that perhaps intelligence is broader than we imagine, and that we may already be living within the mind of a system greater than ourselves, whether or not it is aware in ways we can measure. What if memory were not only something held by living beings but also something woven into the earth itself, stored in matter and energy, waiting to be read by those who know how to look? When we think of memory, we imagine recollection, the act of remembering. Yet on a planetary scale, memory is different. It is not active recall but quiet recording, marks left in layers of stone, in the chemistry of oceans, in the faint isotopes sealed inside ice. The planet does not tell its story aloud, but it carries traces of every chapter. If we pause gently here, we see that Earth holds memory as patiently as a diary written over billions of years, though in languages we are still learning to translate. Now we linger on the mechanisms of such recording. Sedimentary rocks are formed from particles that settle in layers. Each layer traps fragments of shells, pollen, ash, or dust, small pieces of what the world was like when it fell. Over time, compressed and hardened, these layers become pages in Earth's archive. In ice, bubbles of ancient air are sealed, preserving the composition of the atmosphere as it once was. Even tree rings form a record, each ring a measure of growth shaped by rainfall, temperature, and soil. Together, these are forms of memory, inscribed slowly but with extraordinary persistence. But our understanding is never complete. Gaps remain where erosion has erased chapters, where heat has transformed stone beyond recognition, where archives are buried too deep to reach. Memory on Earth is imperfect, layered, and rewritten. The absence of clarity does not mean the absence of record. It means that memory, like life itself, is fragile, partly lost, partly enduring. Still, the language of traces reveals much. The ratio of oxygen isotopes in ice shows us the swings of ancient climate. Layers of volcanic ash in sediments mark eruptions that changed skies for years. Fossils of leaves, with their patterns of veins, tell us the levels of carbon dioxide in air long vanished. Even magnetic minerals in rocks align with the field of the Earth at the time they formed, giving us a record of how the magnetic poles wandered. Each clue is small, but together they form memory written not in words but in matter. Let us imagine, softly, a thought experiment. Step 1. Picture Earth with no memory, its surface wiped clean by constant renewal, every change erased. We would see only the present, with no knowledge of how it came to be. Step 2. Picture Earth as it is, with memory embedded in layers, some clear, some hidden, each offering hints of the past. We can read ice cores to know the breadth of ancient skies, we can study rocks to glimpse vanished oceans. Step 3. Look ahead into the future, when present traces will themselves be sealed into layers, perhaps to be read by others long after us. In this view, memory is continuous, but not for us alone. The conclusion is gentle and without finality. Earth remembers, though not in the way we do. Its memory is slow, patient, and often incomplete, yet it endures across scales of time far beyond our own. Whether we see this as the memory of an organism or simply the consequence of natural processes does not matter. What matters is that the past is not gone. It is stored all around us, waiting in stone, ice, and soil. To rest with this thought is to feel ourselves within that memory, part of the record being written now, one more layer among many in the patient diary of the planet. What if Earth carried not only memory but also rhythms, as though time itself moved through the planet in pulses and cycles, much like a heartbeat that spans millennia. When we speak of time, we often think in years, in decades, perhaps in centuries. Yet Earth keeps a longer calendar. It records cycles of ice and warmth, of sea rising and falling, of continents drifting and colliding. These are not repetitions in the strictest sense, but recurring patterns, the planet's own way of breathing across deep time. If we pause gently here, we may sense that Earth does not simply move forward in a straight line, but sways, shifts, and returns in rhythms both steady and irregular. Now we linger on the mechanics of these cycles. Earth's orbit around the Sun is not perfectly stable. It wobbles, tilts, and stretches in patterns called Milankovitch cycles, unfolding over tens of thousands of years. These subtle shifts change how sunlight falls on the planet, nudging climates toward ice ages or warmer period. Oceans, too, have rhythms. Vast currents that take centuries to complete their loops, swinging heat between poles and equator. Even the crust shows cycles, with continents gathering into supercontinents and then drifting apart again, a rhythm that takes hundreds of millions of years. Each of these processes is slow, but together they create the long pulse of Earth. We must admit our limits here. Many cycles overlap and their effects blur. Some are regular, like orbital changes we can calculate, while others, like volcanic activity, appear irregular, leaving patterns only in hindsight. The absence of perfect predictability does not mean absence of rhythm. It only reminds us that the dance of Earth is complex, with steps we have not yet fully mapped. Still, the language of traces tells us much. In ice cores, we see repeating rises and falls of temperature, spaced across tens of millennia, aligned with orbital cycles. In sediments, we find rhythmic layers, thin and thick bands recording seasonal or climatic shifts over long spans. In mountain belts, we see evidence of supercontinents forming and breaking, their cycles written in folded stone. Each record is a metronome of deep time, steady enough to guide us, even if incomplete. Let us imagine, softly, a thought experiment. Step 1. Picture Earth as if it were silent, with no cycles, no repetitions, only random change. The planet would drift from state to state without pattern, its climates unpredictable, its surfaces unrooted. Step 2. Picture Earth as it is, with cycles guiding its shift. Ice advances, then retreat. Seas rise, then fall. Continents join, then scatter. Each change is vast, but each also carries echoes of what came before. Step 3. Picture Earth far in the future, with new cycles unfolding, ice perhaps returning, continents moving once again toward union. The rhythms continue, indifferent to us, yet steady in their persistence. The conclusion is quiet and without finality. Earth moves in cycles, some that we can read, others we only sense. These rhythms are not perfect repetitions, but they remind us that the planet is not drifting without order. Whether we think of them as the slow heartbeat of Earth or simply the outcome of celestial mechanics and geology, the effect is the same: a sense of continuity, of time folded back upon itself. To rest with this thought is to feel that we, too, live within these rhythms, small and brief, yet part of a pulse that stretches across ages, linking us softly to the larger breath of the planet. What if Earth not only shaped life but also carried the seeds of possibility for life beyond itself, as though it were part of a wider experiment in the cosmos? When we gaze at the night sky, we see countless stars, each perhaps with worlds of its own. Some of these worlds may be barren, others rich, and a few may carry the fragile conditions for living forms. Yet our only example remains Earth, the one place where we can study life in depth. If we pause here, we realize that our planet is both unique and not necessarily alone, a singular case and at the same time a hint of something larger. Now we linger on how scientists explore this question. They look at exoplanets, planets orbiting distant stars, searching for those in the so-called habitable zone, where liquid water could exist. Light passing through their atmospheres may one day reveal chemical fingerprints of oxygen, methane, or other gases that could suggest biology. They also study extremophiles on Earth, organisms that survive in boiling springs, deep ice, or acidic lakes, to expand our sense of what life might endure elsewhere. These methods are cautious, indirect, but they open windows into possibilities beyond our reach. Yet we must hold our conclusions lightly. No confirmed evidence of life beyond Earth has yet been found. The distances are vast, the signals faint, and our instruments still limited. The absence of proof does not mean absence of life. It only means the search is young, and the universe immense. Still, the language of traces gives us guidance. The faint wobble of stars reveals unseen planets tugging at them. The chemistry of meteorites shows complex organic molecules, building blocks of life arriving from space. The isotopes in ancient rocks on Earth hint that life began here quickly after conditions stabilized, suggesting that life may not be as rare as it seems. Each clue is small, but together they whisper of wider patterns. Let us imagine, softly, a thought experiment. Step 1. Picture Earth alone, the only living world in a silent universe. In this view, life is a singular event, fragile, perhaps unrepeatable. Step 2. Imagine instead that life is common, arising wherever conditions allow. In this view, planets are not isolated, but like seeds in a field, some sprouting, some dormant, some withering. Step 3. Imagine still further that life is not only common but interconnected, sharing elements and molecules through comets, meteorites, and cosmic dust. In this vision, Earth is part of a wider web, its biology linked to processes beyond itself. The conclusion is soft and without finality. We cannot yet know if Earth is unique or one among many. What we can say is that the planet carries the full story of life as we understand it, a story that may echo elsewhere in ways we cannot yet detect. To rest in this thought is to feel both the intimacy of our world and its possible place in something greater, a reminder that whether we are alone or not, the living Earth is already a wonder vast enough to fill the imagination. What if the universe itself were alive, and Earth only a small cell within its vast body, carrying out its functions quietly, perhaps without even knowing its place in the whole? This idea stretches our imagination, yet it invites us to think of scale differently. We often place life within planets, contained and local. But what if planets, stars, and galaxies were parts of a much larger organism, with processes that resemble metabolism, circulation, or even thought, only too large and too slow for us to perceive? If we pause gently on this possibility, we begin to sense Earth not as isolated, but as a participant in a cosmic physiology. Now we linger on how such a vision could be framed in simple terms. A living being takes in energy, transforms it, and releases it again. Earth does this with sunlight, absorbing warmth, producing movement in winds, waves, and living systems, and releasing heat back into space. On a grander scale, stars burn hydrogen, turning it into heavier elements, dispersing them through supernovae. Galaxies circulate matter, recycling it into new stars and planets. These patterns echo biological processes, not identical, but parallel, hinting at structures that could be viewed as cosmic metabolism. Yet we must remain cautious. To call the universe alive is not a claim we can test. Consciousness, intention, or sensation on such scales are beyond our tools to measure. The absence of evidence is not evidence of absence, but it reminds us to step softly, to use metaphor as a guide, not as proof. What we can say is that the structures of the universe mirror the structures of life in ways that invite reflection. The language of traces still speaks here. In the distribution of galaxies, we see filaments that resemble neural networks, with clusters connected by threads of dark matter, not unlike nodes and synapses. In the background radiation, we see faint imprints of the early universe, a kind of memory echoing through time. Even the balance between matter and energy, expansion and gravity, carries the sense of regulation, as though the cosmos itself maintains its own equilibrium. Let us imagine, softly, a thought experiment. Step 1. Picture the universe as purely mechanical, vast but inert, moving only by blind laws, without resemblance to life. Step 2. Picture the universe instead as an organism, where stars are like cells, galaxies like organs, and cosmic filaments like veins. Each part functions locally, but together they create a whole far greater than its parts. Step 3. Imagine Earth within this whole, not the center, but a participant, carrying out processes that contribute to the balance of something larger. From this view, life on our planet becomes not an exception, but one expression of the universe's own unfolding. The conclusion is soft and open. We cannot know whether the cosmos is alive in any sense we recognize, yet the patterns we observe resonate with those of living systems. Perhaps it is only an analogy, or perhaps it hints at a deeper truth, one hidden beyond our reach. To rest with this thought is to feel Earth not as a solitary island, but as part of a wider body, a single strand in the fabric of a universe that may itself be more than matter, more than energy, a presence that breathes across the endless spans of time and space. What if consciousness itself were not confined to human minds or even animal brains, but a wider property, diffused through matter and energy, with Earth perhaps carrying its own form of awareness? When we speak of consciousness, we imagine the inner sense of being, of knowing that we know. Yet some philosophers and scientists have wondered if awareness might not emerge only at one scale but instead appear as a spectrum, with different layers and intensities. In this gentle view, consciousness would not be a light switched on suddenly, but more like a glow, varying in brightness across different forms. If we pause softly here, we can let go of rigid definitions and explore the idea that Earth itself may carry a subtle consciousness of its own. Now we linger on what this might mean in practical terms. If consciousness is the ability to register the world, to respond, and to integrate experience, then Earth already shows these qualities in slow forms. It registers sunlight and redistributes it through climate. It responds to imbalances with feedback loops that restore partial stability. It integrates events across scales, with volcanoes influencing skies, forests influencing oceans, and oceans influencing air. Each process interlinks, forming a web where causes and effects are constantly woven back into the whole. This is not consciousness as we know it, but it has echoes, gentle reminders of what awareness might look like in other guises. Still, we must be cautious. No direct evidence tells us that Earth has experiences, thoughts, or sensations. To attribute awareness is to stretch a concept we do not fully understand even in ourselves. The absence of proof does not close the question, but it reminds us to speak with humility, to see this less as a claim and more as an exploration of possibility. The language of traces still guides us. When forests are cut, rainfall patterns change, as though the land feels and reacts. When seas warm, currents shift, altering climates elsewhere, a chain of responses across distances. Even the magnetic field, pulsing and reversing across ages, is a form of dynamic regulation, a planetary rhythm that protects life from harmful radiation. Each of these is indirect, but together they create a sense of coordination, as if Earth systems were aware of one another, balancing across time. Let us imagine, softly, a thought experiment. Step 1. Picture consciousness only as we know it, limited to individual minds, isolated, each separate from the world. Step 2. Expand the view to see consciousness as layered, where cells have their own responsiveness, where ecosystems integrate signals, and where planets might host still broader awareness. Step 3. Imagine Earth across time, its systems adapting, cycling, enduring, and ask gently whether this persistence might carry its own kind of sentience, not in words or images, but in rhythms, flows, and balance. The conclusion is delicate and open. We cannot claim Earth is conscious, nor can we entirely rule out the possibility that awareness extends beyond the boundaries of brains. What we can say is that Earth behaves in ways that suggest sensitivity, memory, and adaptation, qualities we associate with life and, in gentler terms, with mind. To rest with this thought is to soften the edges of what we mean by consciousness, and to sense that perhaps we are not separate minds looking out at an inert world, but part of a wider field of awareness, shared in ways we are only beginning to glimpse. What if, in the very end, the question itself is the answer, not whether Earth is truly part of a larger organism, but that our search for meaning brings us to see patterns, connections, and rhythms that guide us gently toward humility. When we step back, we find ourselves within scales so vast that our own lives seem like brief flickers, yet they, too, are part of the whole. Earth turns, cycles unfold, stars are born and die, galaxies stretch outward, and we are carried within these motions, like waves within a tide. If we pause here, we can sense that the mystery is not meant to be solved completely, but lived with quietly. Now we linger on what we have traced. Earth breathes in climates, remembers through stone, pulses in rhythms of ice and fire. It may not think as we do, but it responds, adapts, and endures. The universe may not live as we define life, yet it circulates matter and energy with a persistence that mirrors vitality. Consciousness may not belong only to us, but might flow more broadly, through systems and patterns, in ways we cannot yet measure. Each of these ideas rests not on certainty, but on analogy, gentle reflections that remind us how little we know and how much remains open. Yet the limits of our knowledge are not failures. They are the spaces where imagination and science meet, where humility deepens rather than ends inquiry. The traces still speak. In layers of ice, in sediments, in fossils, in the faint glow of cosmic background radiation, we see the records of processes older and wider than ourselves. These are the footprints of the possible organism we have wondered about, not proof, but reminders of coherence, resilience, and order. They tell us that the world, and perhaps the universe, carries memory and rhythm, and that by listening we become part of that story. Let us imagine, softly, one last thought experiment. Step 1. See Earth as nothing more than rock and water, without life, without pattern, drifting through cold space. It would still be immense, but silent. Step 2. See Earth as it is, alive, layered, cycling, filled with the quiet persistence of adaptation. It is not only a planet, but a cradle, a record, a process. Step 3. Let the vision expand outward, seeing Earth as one cell among many, part of a larger body we do not yet recognize, whether that body is the living universe, or only a metaphor we use to capture its vastness. In each view we learn something, and in none do we reach final certainty. The conclusion is soft, as it must be. We cannot claim to know if Earth is part of a cosmic organism, yet in asking the question, we have learned to see our world differently, not as separate but as woven into cycles, patterns, and possibilities larger than ourselves. To rest with this thought is to let go of the need for final answers, and instead to feel the calm of belonging to a mystery that stretches beyond our reach. If this rhythm speaks to us, we know that we may return, gently, to listen again.